Okay, now we're going to look at polynomials in several variables. We're going to be evaluating a polynomial in several variables. First thing you do is substitute the given value for each variable, then perform the resulting computation using order of operations. So I've got this expression, x needs to be -2, y needs to be 3. So let me substitute in. I always substitute using parentheses, especially if it's a negative number. Okay, so I've substituted. Order of operations dictate if you see any exponents, you need to go and evaluate those. So remember, this is multiplication here. -2 to the third. Since I have 3 bases that are negative, I'm going to end up with a negative, and it will be an 8. I still have a -2 here. Okay, so all the exponents are done. Now I do have parentheses, but I do not have to worry about simplifying. And that's why I didn't look at, because technically you're supposed to look at, if you remember, please excuse my dear Aunt Sally, P is for parentheses, but you only worry about those if you've got something other than a number in there. And since all of my parentheses just had -2, I didn't have to worry about that. Then I did exponents. Now, after that's my dear, which is multiplication division in the order in which it occurs. So I've got multiplication here, I've got multiplication here, and here. So I've got 2 times -8 would be a -16, times 3 would be a -48. This, I'm going to have a positive, so whatever sign I end up with, this will be the one that I need, so that'll be a -18. That'll give me a -14 minus 3. So now I add, subtract. It's the last thing I have to do, and since I have all subtraction, if all my signs are the same, technically I add the numbers and use the signs. So I know it's going to be a negative something. See, 14 and 3, that would give me 17. 18, that'd be 35. 13, so it looks like I should have a -83. I'm going to revisit this problem after I finish the rest of these, but I'm going to show you how you can store numbers on your calculator and type the expression in to check yourself. Now, the degree of a polynomial in 2 variables is the highest degree of all its term. So, using the vocabulary of polynomials, we need to determine the coefficient of each term, the degree of each term. Now, if there's more than one variable, you just add your exponents of all the variables. The degree of the polynomial, so it'd be the largest sum of the prior exponents. So my numerical coefficient, or shortened to coefficient, for my first term, that would be 7. This one would be -17. This would be a 1, -6. I do have 9 there. So the degree of each term, so that would be a 5 here. So let me write it, I'll just write it under it. This would be a 6. This would be 2. Remember, both of these have an exponent of 1. This would be a 2, and this would be a 0. So now that's the degree of each term, but the degree of the polynomial, the largest I've got, is this one. So the degree of this polynomial would be 6. So let me move it on up. Back to adding polynomials and eventually subtracting. Get rid of parentheses. And since I have plus signs in front of all my parentheses, I change no signs. Uh-oh, I left out my y. So these are the same variables, so I add their coefficients, so that would be 15xy squared I have xy here, so negative 5 plus 2 is a negative 3 xy, plus 7 minus 6 is a positive 1. So that would be my answer for that one. Now I've got subtracting. If you remember about subtracting, any parentheses that's preceded by a negative, all signs change. Remember, this is understood to be a positive, so no signs change in that one. This one, that changes to a negative. That one changes to a positive, to a positive, to a negative. So I've got that one and that one. Give me a negative 3x squared y. Be a plus 5xy squared. And my constants would give me negative 7. In order for me to combine like terms, their variable pieces must be the exact same thing. So I've got one more page on this one. Move it back down. Because now we're going to be multiplying. Now remember, in your multiplication, our rule is if I have a base raised to a power times same base raised to a power. Could be the same, could be different. This is the product rule. I keep my base, but I add my exponents. So you've got to know that rule in order to do this type of problem. So I've got a monomial times a monomial. So I've got 7 times 5, so the coefficients get multiplied. X squared times x cubed would give me x, add those exponents. Y times y squared would give me y cubed. That would be my answer on that one. Now I've got a monomial times a polynomial, so this gets distributed all the way through. So it's sort of like doing multiple monomial times monomials. So the first one, 3 times 4 would give me 12. X squared, x cubed, x to the 5th, y times y squared is y cubed. So that one's done. 3 times negative 6 is a negative 18. X to the 4th, y squared. This one times my very last, all I have to do is multiply that by 2. So I'm going to have a plus 6 x squared y. And that's it. Multiplying polynomials in 2 variables. If you'll notice, I've got a binomial times a binomial, so I'm going to FOIL. X times 3x, 3x squared, x times the last. And always put the variables in alphabetical order, because that way you can tell if you've got like terms. So that's the F and the O. So the inside is a plus 12xy. Last times last is a negative 20y squared. I do have like terms. There. Now I want you to pause me and you do the next one, either by writing this out twice and foiling or using that formula that we've got. So it's up to you. I don't care which way you go. So pause. And if you went binomial times binomial and used the FOIL method, you should come up with the exact same thing. And remember, I do not care. So I've got some more multiplication down here. So do those. Let's see what you end up with. So pause me. I'll go ahead and multiply. We'll see what we come up with. Ooh, that term and that term's the same. That term and that term's the same, but the signs are different. So I should be able to not worry about the O and the I. 16x to the 4th y squared. Now if you had foiled that one, you would notice that the O and the I eliminate each other. So again, If you notice it, fine. If not, multiply. This one, I'm going to distribute my x all the way through. And then I'm going to take my y through. This is called the sum of perfect cubes. We will eventually have to be able to factor that, but that's sort of neat though. I did say I'm going to try and use my calculator. I'm still having issues. So I'm going to get that problem back. I'll raise this up so maybe you can see the whole calculator. We'll see. Well, I had to pause me so I could go find some batteries. So the first thing I've got to do is store the -2. And again, this is the value for negative. This is only for subtraction. So -2. There's an STO here. That means store. And then I'm going to put it in for x. You press enter to tell the calculator, yes, I'm sure this is what I want to do. I'm going to go 3, store in. Now on here in green, I don't know if you can tell, hopefully you can on your calculator, I've got the whole alphabet. I have to press alpha, and if you'll notice my cursor goes to alpha mode, and then number 1 is where my y is, and then I press enter. Okay, now I just type in this expression exactly how I see it. So I've got 2x to the third. I got to move. This is the new operating system. If you have the old one, you'll have a little symbol that looks like that. Times y, so I got to do alpha y, plus x alpha y, and this is a quick key for square, plus 7x minus 3. Let's see, hopefully you can see that. Oh, that's not too bad. So now I've stored in my values. I typed in the expression exactly how I see it. Now when I press enter, I hope I'll have -83. And I do. So you can do it longhand. You can double check this way. You need to start playing with this calculator and be able to use it. Okay, that's it for this video. Thank you.